Alright everyone, so today I'm going to go through a series of 10 problems involving parallel lines and transversals. And if you're watching this video right now, you are inside of Edpuzzle, which is a video platform software that I use to make videos. And the thing that's special about Edpuzzle is I can embed questions in the video that I want you guys to answer. So the way this is going to work is I'm going to show you the problem. I want you to, and the video is going to stop after I show you the problem. I want you to try to solve it. Do your best to try to solve it. And Edpuzzles is going to ask you for the answer. So you're going to go ahead, try your best, put your answer in, and then after you put your answer in, the video will play again and it will show me working out the problems. Now keep in mind that I'm going to be grading this, and I'm going to be grading the first 5 problems for accuracy, but I'm going to give you a participation grade for watching the entire video. Now, what's special about Edpuzzle also is that I can see who watched the video and who did not. I can also see your answers. I can see what time you were in the video, how much of the video you watched, how many times you rewound it. I can see everything. So make sure you watch the whole thing so that you get full credit. Okay, good luck. Okay, take a few minutes to study this problem, and I want you to tell me 2 things. First, tell me the angle relationship that you would use to solve this problem, and then actually solve for x. And please input your answers into Edpuzzle, and then after you do that, you will be able to see me work out the problem. So looking at this problem, it tells us that L and M are parallel. L and M, and T is our transversal. So to solve this problem, we're going to use alternate interior angles. And we know that alternate interior angles are congruent. So we're going to set these 2 angles equal to each other like this. We're going to have 5x plus 9 equals 84. And you want to go ahead and either solve that manually or put it in InSolve. Okay, so I put the equation in InSolve and I got x is equal to 15. And I'm going to check the directions for the problem, and it says find the value of x. We did that. We got x is equal to 15, so we are done with this problem. Alright, let's do the same thing for problem 2. Tell me the type of angle relationship that you're going to use to solve this problem, and then actually solve for x. Input your answers into Edpuzzle, and then you'll be able to see me solve the problem again. This is the way it's going to work for every problem. Alright, so looking at this problem, my angles that I'm solving for are here and here. So to solve for x, we're going to use the angle relationship of consecutive interior angles. Consecutive interior angles. And I know that consecutive interior angles are supplementary. So since they're supplementary, I just need to add each angle together and set it equal to 180 degrees. So my first angle is x plus 72. That's this angle. Then I'm going to add it to this angle, plus 3x. That's this angle. And I'm going to set that equal to 180 degrees. And now you can go ahead and solve that by hand, or you can put it in InSolve in the calculators and find out what x is. Alright, so I entered the problem into InSolve, and I got x is equal to 27. Let's go back and look at the problem, the directions for the problem. It says to find the value of x. We found that x is equal to 27, so we are finished with this problem. Alright, now we're ready for number 3, and this one gets a little slightly more complicated in so much that we have to solve for y. But in my problem I see x's and y is right here. So our ultimate goal is to solve for y. But before I can solve for y, I actually have to solve for x first. So to do x, I am going to look at the two angles that have x's in them, and it looks like those are corresponding angles. And we know that corresponding angles are congruent, so I'm going to set those equal to each other. 4x minus 50 is this angle, and I'm going to set it equal to the other angle, which is 2x plus 30. And now you can either solve that manually, or you can go onto your graphing calculators and do insolve. And let's find out what x is. Alright, I have entered this into insolve, and I have x is equal to 40. Now, if I go back to the directions of the problem, it says find the value of y. Well, I haven't found the value of y yet, I've only found x, so we're not done yet. So what I need to do is I need to look at y is right here, and y is an acute angle. Well, the angle next to it that makes a linear pair is an obtuse angle. So if I know the value of this angle, I can subtract that value from 180 to get y. So what I'm going to do is take this 40 and plug it in for x right here and find out the value of that whole angle right here. So instead of 2 times x, I'm going to have 2 times 40 plus 30. And we're going to see what that is. So when I plug in x and solve that, I get that this angle is 110 degrees. So I'm going to scratch this out because now I know that it's 110 degrees. And you need to ask yourself if that makes sense. This is an obtuse angle, so it should be more than 90 degrees, and 110 is more than 90 degrees, so it looks like we're on the right track. So now all I have to do is I know that this angle that I just solved for and the angle here represented by y is supplementary, so both of those angles have to add up to 180 degrees. So I'm just going to take 180 and subtract 110, and I'm going to get 70 degrees. So y is equal to 70 degrees. Let's go back to our directions. The directions said to find the value of y. We now have y, so we are done with this problem. Alright, we are ready for number 4. So in number 4, it's telling us that line L and line M are parallel, so T is our transversal, and we need to find the value of x. So I want you to enter in your answers for what angle relationship would you use, and then I want you to solve for x. So the angle relationship that we're going to use is alternate exterior. Because the angles are on the outside of the parallel lines and they're on opposite sides of the transversal. And we know that alternate exterior angles are congruent. So we are going to set up our equation. We're going to set each angle equal to each other and solve for x. So x plus 58 is that angle, and it's equal to 4x minus 11, which is that angle. So go ahead and put that in insolve and tell me what the value of x should be. So I entered the equation into insolve, and I came up with x is equal to 23. Going back and reading the directions of my problem, it just tells me to find the value of x. We did find the value of x as 23, so we are finished with this problem. Okay, number 5 is another problem that's asking me to solve for the value of y. And in this problem, I have 3 angles given to me. I have one here, and one here. And I have a mixture of x's and y's. So since I only have one y, I can't really set that equal to anything. but I do have two angles that have x's in them, so I can work with that to solve for x. So in order to find what y is, I need to either find the measure of this angle or the measure of this angle. And to do that, we're going to have to solve for x. So the angle relationship that we are going to use here is alternate interior angles, because both angles are inside the parallel lines and they're on the opposite sides of the transversal. So we know that alternate interior angles are congruent, so I'm going to set these two angles each equal to each other. So I'm going to say 5x plus 30 is equal to 7x. Go ahead and put that in your calculators and do insolve. And when you do insolve, you're going to come up with x is equal to 15. Now remember, I have to go back and read what they're asking me for. They're asking me to find the value of y. Well, I have found the value of x, so I'm not done. Don't stop there. So now what are we going to do with that x? Well, I have a couple of options. I can plug x into this angle and get the value or the measure of that angle, and y will be equal to that value because these are vertical angles. Or I can plug 15 into this x here for this angle and get the value of that angle, and y is also going to be the same as that angle because these are corresponding angles, and corresponding angles are equal. So I think it would be easier to plug 15 into the 7x, so I'm going to plug it in there and do 7 times 15, which is 105. So I am going to scratch out this because I just solved for the measure of that angle. It is no longer 7x. We have found that it is actually 105 degrees. And since y corresponds to this angle, y is also going to be 105 degrees. So looking back at my problem, it said to find the value of y. I have y now, so we have finished this problem. Alright, number 6 at first glance looks a little tricky because I've got a lot of different lines and things going on. But if I read the problem, it says that line L and line M are parallel. And in this case, I have two transversals cutting through the parallel lines. But we're not going to let that scare us. We actually have to solve for x in this problem. So the way we're going to tackle this is I'm actually going to use corresponding angles. So if I start with this transversal and look at the angle that it makes with this parallel line, it actually corresponds with the angle that the transversal makes with this parallel line. So this whole angle, which is 5x minus 16, is equal to this whole angle, but this angle is actually split up into two different parts. Part of it is 2x, the other part of it is 50. So all we really have to do is add 2x and 50 to get the measure of this whole angle. So I'm going to go ahead and write 2x plus 50 and scratch that out. So I just added those together to get that angle. Now, since I have corresponding angles, we know that corresponding angles are congruent, and if you forget about that, this angle is obtuse, this whole angle is obtuse, so they have to be equal to each other. So let's do that to solve for x. Let's take this angle, 5x minus 16, and let's set it equal to this whole angle, which is 2x plus 50. And we're going to insolve that and figure out what the value of x is. Okay, so I have insolved that, and I get x is equal to 22. Alright, so go back and read your directions. It says find the value of x. We did that. We found the value of x is 22. So problem 6 is now complete. Alright, so we are ready for problem 7. Go ahead and take a look at it, study it for a few minutes, and see if you can come up with the answer on your own. It looks a little bit different than other problems that we've had, but I'll give you a hint. Even though this is a triangle, it tells us that AE, so AE is the bottom line, and BD are parallel. And I have these angle measures here, but this line here, CE, is the transversal that cuts through the parallel line. So if it helps, you can actually extend the parallel lines a little bit. You can extend any line actually. And let's see if that helps you out. So take a couple minutes and see if you can solve this problem on your own. You are looking for the value of y. Okay, hopefully you were able to solve that, but if not, no worries. We're going to work through it together right now. So in order to find y, I need to... It looks like I'm going to have to solve for x first because I only have one expression that has y in it, so I can't really set that equal to anything else. But I have two expressions that have the variable x in it, so let's do something with that. Well, the angle relationship that I'm going to use is corresponding angles. 4x minus 5 corresponds with this angle down here, 97 minus 2x. And if you forget about corresponding angles, which happens a lot, just look at the eyeball, the measure, the angle measure. It looks like it's an acute angle here and an acute angle here. And remember, when we have acute angles together, they are equal to each other. Corresponding angles are equal to each other. So let's do that. Let's set 4x minus 5 equal to 97 minus 2x. Put that in insolve and you'll be able to find out what x is. Okay, when I put this in insolve, I get x is equal to 17. Now, reading the directions of the problem, it doesn't ask me to find x, it asks me to find y, so we're not quite done yet. So I need to plug x into one of these angles, and it doesn't really matter which one. So I think I will plug it into the top one here, 4x minus 5. So I'm going to say 4 times 17 minus 5. All I did was sub 17 in for x. And we're going to solve that little equation, or we're going to solve that expression and see what x is, or see what the angle measure is. So 4 times 17 minus 5 is 63. So I'm going to come up here and I'm going to scratch out this because now I know that the measure of this angle is 63 degrees. So now to find y, what do we have here? I have an acute angle, and the angle that has the y in it is an obtuse angle. So those are actually a linear pair. And remember, a linear pair needs to add up to 180. So I am going to say 10y minus 3, which is this angle. I'm going to add it to 63, which is the other angle. And that needs to be equal to 180 because they are supplementary. So that's a second equation that you need to put into insolve. So when I put that into insolve, I come out with y equals 12. Let me go back and read my directions one more time to make sure I've answered the problem. And it says to find the value of y. I have the value of y now, so we're done. Okay, we are ready to look at problem number 8. And the last 3 problems we are going to do is 8, 9, and 10. And these are a little more challenging. So I want you to go ahead and try them and see what you come up with. Don't get very discouraged if you can't solve them right away because these are a little more complicated and these are not likely to be on the test or the SOL, but regardless, it's still something that you should know how to do in geometry. So let's take a look at number 8. We have a weird shape here, but it tells us that PS, which is the bottom line on this figure, PS, is parallel to QR. So with that parallel line, with those two parallel lines, I have two transversals. I have this transversal here, which is PR, and I also have RS, which is a transversal. So just take a minute and study that and see if you can come up with an answer. Again, it may help if you extend the parallel lines a little bit and maybe extend the transversals a little bit. Sometimes that helps me see the parallel lines a little clearer. So go ahead and give that a try. Okay, so what they are asking for is to solve, or actually find the measure of angle RSP. So RSP. RSP. So we're ultimately looking for the measure of this angle right here. So looking at that, I can see that this angle with 2x plus 1 is an acute angle formed by the parallel line and the transversal. So I'm going to come up here along the transversal, and I need to get the consecutive interior angle. So that's the angle formed by the transversal and the parallel line. So these are consecutive interior angles now. But look what happens. I've got 2x plus 1, I've got a 3x, and they've thrown in this 5y. So right now there's not much I can do with these relationships. So if I knew the value of y, I could turn this into a number and be able to solve this. So let's see if we can find a way to solve for y first. Well, I immediately see that 5y plus 14, that angle, and this angle down here are alternate interior angles because they're on the inside of my parallel lines and they're on opposite sides of the transversal. So that means they are congruent. So let's set them equal to each other. 5y plus 14 is equal to 8y minus 13. We're going to insolve that and figure out what y is. So plugging that into insolve should give you y is equal to 9. So now I know that I need to figure out the measure of this angle so that I can find the measure of this whole angle, so this angle that I drew right here is split into two different parts. Part of it is 5y plus 14, the other part is 3x. But now I know what y is, so I'm going to plug my y value, which is 9, into this expression. So I'm going to say 5 times 9 plus 14, and that should give us 59. So I'm going to scratch this out, and I know now that the measure of that angle is 59 degrees. So to get the measure of this whole angle right here, it's just going to be 3x plus 59. So I'm going to scratch both of these out and write 3x plus 59. Now I can use consecutive interior angles to solve for x, because I have to know what x is before I can solve for RSP. So we know that consecutive interior angles are supplementary. And these are consecutive interior angles because both of these angles are on the inside of the parallel lines and they're on the same side of this transversal. So I'm going to say 3x plus 59 plus this angle plus 2x plus 1, that's this angle. Those are supplementary, so we're going to set them equal to 180 and plug that equation into insolve. When I do that, I come out with x is equal to 24. So now I'm almost there. I've solved for y, I've solved for x. Ultimately, I need to know the measure of this angle. So I know this angle is 2x plus 1, but I found x to be 24, so let's just plug it in. So 2 times 24 plus 1 is going to give you 49 degrees. So going back to the directions for the problem, it said to solve for angle RSP, which is RSP. So I'm going to mark this out, and I now know that that's 49 degrees. So that was a little complicated, but not too bad. So we are ready to... All right, let's look at number 9. We've got 2 more problems to go. So this problem is what I call a hashtag problem. And in the directions, it's telling us that L, this line, and M, this line, are parallel, but also J and K are parallel. And they want us to find the value of y, which is sitting right here. But I don't have any other y's or any other numbers that I can set that equal to. But I do have two angles here that have x's in them, so I can probably do something with that. And I can because looking at line L and M, they're parallel. Line J is the transversal I'm going to look at. And these two angles are consecutive interior. They're consecutive interior because they're inside the parallel lines and they're both on the same side of the transversal. So they are supplementary angles. So I'm going to take 5x and I'm going to add it to the other angle, which is 7x plus 24. And since they're supplementary, it has to equal 180 degrees. So I'm going to put that in insolve and find out what x is. Okay, after I insolved it, I found out that x is equal to 13. So now I have a couple options. I need to solve for y because the problem says solve for y and I still haven't done that. I only have x. So what I'm going to do is I notice that 6y plus 7 is an obtuse angle, and this angle down here is also obtuse. So what I'm going to do is plug in, so that means they're going to be congruent. So I'm going to plug x in here to the 7x plus 24. So I'm going to have 7 times 13, which was our x value, plus 24. And we're going to solve that. So solving that, 7 times 13 plus 24 gives me 115 degrees. So I'm going to scratch this out. And I'm going to write 115 degrees. That is the measure of this big obtuse angle. Well, this big obtuse angle is going to equal that. So let's set these two things equal to each other. So if I do that, I'm going to have 6y plus 7, which is this angle, is going to equal this angle, which we found to be 115 degrees. Now all you have to do is plug that into insolve and figure out what y is. Alright, when I plug that into insolve, I get y is equal to 18. And looking at the directions, it said to find the value of y. That's what I did. I have y equals 18. So problem 9 is complete. We're ready to go on to the last problem. Alright, we are ready for our last problem, problem number 10. And this is also our most challenging problem. So I would encourage you to go ahead and give this problem a try. Don't get discouraged. It is a little challenging. But I'm going to go ahead and give you a couple of hints that will help you solve the problem. So reading the directions, I know that line L is parallel to line M. So those are my parallel lines. Line J is a transversal, and line K is also a transversal. So the key to solving this problem is recognizing that vertical angles are congruent. That's the first key. So I know I have a 4x here. So that makes this angle right here 4x also, because vertical angles are congruent and vertical angles are across from each other. But I also know that this angle right here is 90 degrees. And I know it's 90 because this box means that this angle is 90 and the vertical angle is equal to it, so that is also 90. So the next key to this problem is I'm going to have to solve for x before I can solve for y. So I'm going to look at this angle down here. It's a big obtuse angle right here. And it is formed from this transversal and the bottom parallel line. Well, I can find a corresponding angle if I follow the transversal up and draw this angle from the transversal all the way up to the other parallel line. So that's corresponding angles, and these angles are congruent. So that's the only hint I'm going to give you, and I want you guys to go ahead and give that a try and see if you can at least get the x. Alright, so how did you do? Were you able to solve it? Did you get frustrated? It's okay if you couldn't solve it, because I'm going to do it for you now. Okay, so I said that this angle corresponds with this whole angle. But this whole angle is split into two parts. This part is 90 degrees, this part is 4x. So to get the whole angle, I just need to add these two together. And that will be equal to this. So this whole angle right here is 4x plus 90. And that's going to correspond to this angle, and we know corresponding angles are equal. So I'm going to set it equal to 11x minus 8, that angle. And just like in all of our other problems, we are going to put that in InSolve and find out what x is. So when I put that in InSolve, I get x is equal to 14. But we're not done yet because they don't want to know what x is. They want to know what y is. So now I'm going to shift gears and use this transversal, because this little angle right here where the 4x is corresponds with this little angle right here where the y is. And we know that corresponding angles are equal, so I'm going to set this equal to this. But before I can set it equal, I need to know, I have an x and a y. I can't set those equal to each other. I can't have two variables. But I know what x is, so I can plug it in right here. So instead of 4x, I'm going to have 4 times 14. And I got that just by plugging in x. So 4 times 14 is 56. So I'm going to scratch out this 4x and write 56 degrees, because that's the measure of this little acute angle, which is going to be the same as this little acute angle. So now I can say 9y plus 2 is equal to 56. And we're going to InSolve one more time to find out what y is. Alright, when I put that in InSolve, I got y is equal to 6. Checking my directions again, it said to find the value of y. I just found the value of y. It is 6, and so I'm done with this problem. So again, 8, 9, and 10 were pretty challenging. You probably won't see anything that challenging on the SOL, but it could show up as a bonus problem in one of my tests that I give you. So I would rewind the video if you want to and just review these as many times as you want. I'll leave this up on Canvas, and hopefully it will help you get some extra points on a test possibly. Alright, thanks a lot for paying attention and participating.